forward, but you have the unfortunate capability that you don't get to see me in person, but that's okay. I know you're going to be just fine without my beautiful face in front of you. All right, so today we're going to be talking about composition of functions, and we're going to be talking about kind of number monsters and how we can combine different numbers together and different functions together and make a new function. And we're really going to stick today with just addition and subtraction, multiplication, and division. And then on Monday, we're going to go with a different kind of composition of functions. So we're going to start with just addition. So we have one function, and our first function, we're going to call it our green function here, is f of x equals 3x squared minus 4. Our second function, make it our red function, is a g of x function. Our g of x equals 4x plus 5. So when they say we need to take f of x plus g of x in this first problem, what we're going to do is we're just going to take our first function and we're going to add it to our second function. So we're going to take 3x squared minus 4 and we're adding it to 4x plus 5. Okay, so we just need to add those two things together. And really, we just have to do that. We're going to add across. There's no multiplication involved with this one. We're just adding like terms. So the like terms we have, there's no x squared terms that are alike. There's no other x term except for the 4x. The two that are alike are the minus 4 and the plus 5. Negative 4 and a positive 5 makes a positive 1. So our answer in the end is 3x squared plus 4x plus 1. Same process for subtraction. Very similar. I'm going to take my f of x, which was 3x squared minus 4, and I'm going to subtract my g of x, which is 4x minus 5. So notice how I kind of got rid of the g of x and the f of x. If f of x is equal to 3x squared minus 4, then I can substitute it in instead of this f of x. Same thing, if g of x is equal to 4x plus 5, I can substitute it in for that g of x. Now, the problem here just becomes, how do you do subtraction? Well, when you subtract, you just have to subtract each and every term. Biggest thing is it turns that minus 5 and that 4x minus 5 into a plus 5. And then you're combining like terms. Our like terms would be the negative 4 and the positive 5, and it would make it plus 1. So it just kind of happened, and I made a mistake. I'm just realizing that. Sorry, guys. I told some of you guys I make mistakes here and there. I had made a mistake here. We're going to leave it in because I know that happens sometimes. I should have put a plus 5 here in my original, which means this would be a minus 5 when we do subtraction. Now, our answer here is going to be minus 9. Anybody talking back to your to the board here? You might have known that. All right, so here, you probably have, I think, a box here. It's hard to get that multiplication dot in, and it's hard for us to do that on the computer too. I don't know why I got this little thing. That's a multiplication is what we want you to do. So if you have a little kind of empty box, know that what we want you to do is multiply. So now we're going to take our f of x term, which is 3x squared minus 4, and we're multiplying it by our g of x term. Our g of x term is 4x plus 5. Sorry about that, guys. I do these after school, and they make announcements after school. What we need to do is I need to split up these two into two parts. I need to split up the 3x squared and the minus 4. Usually at your first grouping, you're going to split up each term. So I'm going to split up the 3x squared, and I'm going to multiply that by 4x plus 5. And I'm going to split up the minus 4, and I'm going to multiply that by the 4x plus 5. So now I'm doing the distributive property. That's what I'm looking at here. I'm looking at doing distributing out that multiplication in both instances. So let's do that distribution. I'll move this up a little bit here. All right, 3x squared times 4x is 12x to the third. 3x squared times 5, 15x squared. Minus 4 times 4, minus 16. X, it was 4x, sorry, minus 4 times a positive 5, minus 20. So having our math skills kind of sharp is really going to be helpful. Now we're going to look for like terms. There are no like terms to combine And so you're done. That is our answer. There were no terms that were alike. All right? So that was it. Now we're going to look here at f of x and g of x. This one is kind of probably the most kind of confusing, but then in the end it turns out you do the least. So the g of x was 3x squared minus 4. The f of x is 4x plus 5. There's not a lot else you could do with this. You could try to factor the numerator and factor the denominator. That doesn't help us much. Actually, that's our answer. And for division, a lot of times with our stuff, I want you to know kind of that concept. I don't have to have it simplified perfectly. All right, so notes for adding. When we're adding two functions together, the big things you need to keep in mind, you're just adding the terms of the first function, terms of function 1 with the terms of function 2, all the terms. And then you just need to make sure you go back through and you need to combine like terms. Combine like terms. All right. Next one, subtracting, same thing. Your function 1, and you're just going to take away, or you're going to subtract each and every function. This one, you're going to subtract your g of x. All right, so this one, you have to make sure that you subtract every term for your g of x. Each and every term. You're going to change the coefficient, or you're changing whether it's positive to negative, and it's negative to positive. Subtract each term of g of x. That's my big hint. The other thing is you're also combining like terms again. I'm going to put LK for like terms. LT, thank you, LT, like terms. This is our multiplication. All right. So there you're going to multiply the two terms together. So we're multiplying. And the big thing you had to remember is you need to take, split each term. So you're actually splitting each term of your first term and then multiply by your second function. And again, combine like terms. CLT. Division, it's really about rewriting it. It's how you write it out. Or rewrite it. All right? Rewrite as a fraction. There isn't much simplifying. I'm not going to be putting combined like terms there or simplify. There just isn't much simplifying. We're rewriting it and moving on. So let's talk about some more examples. F of x plus g of x in this example. Well, our f of x is x squared minus 9. Our g of x is 2x plus 7. It's really here just about combining like terms. I don't have any other x squared terms. I don't have any other x terms. What I can combine here is the minus 9 and the plus 7. When I combine those two, I get minus 2. And that is my answer. Going to the right when I subtract. Now I have x squared plus 9 minus 2x plus 7. Here, the big problem is I have to subtract. Get rid of that. I have to subtract the both terms, both second terms. So I'm going to subtract the 2x and I'm going to subtract the 7. So now, what I want to do is combine like terms. That's my last thing to do. X squared minus 2x. Now my problem becomes I have a positive 9. How did I have a positive 9 and 1? Oh, I did it again. How am I going to do? Oh my gosh. Sorry about that, guys. It's a negative 9. I'm just copying it down wrong. I apologize. Quality control isn't where it should be. All right. And then now, so I have a negative 9, and I need to combine it with a negative 7. I get negative 16. And that's my answer. Multiplying, I'm sorry, this multiplying didn't turn out well. I'm just multiplying the 2, x squared minus 9, and I'm multiplying it by 2x plus 7. So, you take your first term, x squared, you're splitting those terms. You're multiplying it by the 2x plus 7. You're taking your second term, your minus 9, and you're multiplying it by the 2x plus 7. All right, now it's distributive property. 2x to the third minus 7x squared minus 18x there minus 63. Look and see, can you combine like terms? Sometimes you may. We just happen to have had two problems where we don't. Last, it's a lot about rewriting it. F of x goes in the numerator, x squared minus 9. 2x plus minus 7 plus 7, goes in the denominator. We don't want to simplify that at all, or it doesn't really do us much help to simplify it. Circle it and move on. So, this is your worksheet for tomorrow. Now, the column all the way on the right has what we call, it's kind of like the composition of functions here. We're adding and subtracting functions. I'm going to have you please wait on this third column. So don't do this column. I don't know if you can see. But don't do those when you have, it's called a composition, where it's f of g of x. It's embedded function. So where one function is embedded into the other. If you want to look ahead, if you're bored in class and you want to look ahead and say, hey, I think I can do that, go ahead and look at the book, look at some examples there, and then go ahead and give those a try. It'll just be time ahead. But the only thing you have to get done is the first two columns. All of the addition, multiplication, subtraction, and division. That's all I'm looking for. Thank you, guys. I hope you have a great day. Be good, and be kind. Have a great weekend.